Welcome to the last part of lecture 6. We already touched upon this a little bit briefly when we were looking at a solution to a non-homogeneous and a homogeneous system of solutions, but I want to talk a little bit more briefly, a little more detail about writing solutions in parametric form. So this is something that I will apply not only to the homogeneous system. So what I have written out here is basically the procedure of how one writes solutions in parametric form. One starts by doing what we learned back in lecture 1 and lecture 2 about row reducing your augmented matrix to the reduced row echelon form. And the reason you want to do that is because it makes step 2 very easy. It allows you to express each basic variable in terms of its free variables. Then what we want to do is express a typical solution as a vector whose entries only depend upon the free variables, if there are any. And then finally, what we want to do is decompose your vector X into linear combinations of vectors where we have numeric entries for our vectors and then being multiplied possibly by our free variables as parameters. So I'll give you a worked out example of how to write out our solutions in parametric form. So you can see here at the bottom of my screen is that we have a particular matrix and a vector B, and we want to be able to solve this matrix equation and put it in parametric form. So I'm just going to work out the various steps. Okay. So step 1 said that I have to put it into reduced row echelon form. So I will just tell you how that's done, okay, without going through all the details. So here's my augmented matrix. And if you do all the work, you can put it into the reduced row echelon form as follows: 1, minus 1, 0, 1, 2, 0, 0, 1, minus 1, 1, and then 0, 0, 0, 0, 0. And staring at this, you can easily say which variables are basic and which ones are free. So step 2, let me just remind you what step 2 was. Express each basic variable in terms of free variables. So step 2, first of all, we notice that here are my pivots. So my basic variables are x1 and x3. So that means my free variables correspond to the remaining variables. So they're x2 and x4. So I'm supposed to write my basic variables in terms of my free variables. The first equation tells me that, or sorry, I'll start with the second equation. The second equation tells me that x3 minus x4 is equal to 1. So I'll rearrange that. So I have x3 is equal to 1 plus x4. And the top row tells me that x1 minus x2 plus x4 is equal to 2. So rearranging that gives me x1 is equal to 2 plus x2 minus x4. So here I have written my basic variables in terms of my free variables. And the reason we put it into reduced row echelon form is because if this is a pivot, it kills all the things above it, so we wouldn't have any of the basic variables showing up in rows above them. So it just makes the computations a little bit simpler if you put it into reduced row echelon form. Now step 3 is you want to express a typical solution whose entries only depend upon the free variables. Okay, so let me just show you how to do that. Step 3, I'm going to say, well, I need a typical solution. My typical solution is going to be a vector x, and it will have 4 entries, x1, x2, x3, x4. And I know that x1 in terms of my free variables is 2 plus x2 minus x4. x2 is a free variable, so we leave it as is. x3 written in terms of free variables is 1 plus x4, and x4 was a free variable. Okay, so I've written my typical solution in the following way. And then step 4 is what we want to do is decompose this solution into a bunch of vectors only containing numeric entries and then being multiplied by our free variables as our parameters. Okay, so let me just show you how this is done. So step 4, I can take my x, and now first thing I'm going to do is say, okay, what are all the numbers that show up that do not involve free variables? Okay, so I get a 2 in this in the first coordinate. There is no number by itself in the second spot, so I'll have a 0. I have a 1 here, and in the last guy I have no number by itself, so that's the first guy. Then I'm going to take everything involving an x2. Okay, so I have 1x2 here. I have 1x2 in the second spot, and these two guys have no x2s. And then I have an x4, I repeat it for x4, and I have a -1, a 0, a 1, and a 1. Okay. And what this does here is that this gives me gives me the parametric form. So this, the final thing right here, it is the parametric form of my solution. And you should probably add that x2 and x4 are just arbitrary real numbers, so people looking at your solution know that you mean all the multiples there, and that these are the free variables. So this just gives you kind of an example of the procedure of writing a solution set in terms of its parametric form. We've done this a couple times. We just kind of want to reinforce this particular skill, and it's something you should practice. Okay, so what are the takeaways from today's lecture? Well, kind of 2 takeaways. First of all, you should know the difference between a homogeneous and a non-homogeneous system of linear equations and how their solution sets are related. And also you should be comfortable with the idea of describing solution sets in its parametric form. So that's it for today's lecture. I'll see you in lecture 7. Have a great day.